Welcome to Research Rundown. Today we're diving into a groundbreaking study in astrophysics, titled Quantum Fluctuations in Black Hole Formation. Our expert panel will delve into the key findings, which suggest a revolutionary new understanding of how black holes come into existence. Joining me are two esteemed external analysts who'll put this research under the microscope. On one side, we have Dr. an astrophysicist with a reputation for her optimistic outlook on cutting-edge discoveries. She's convinced that these findings hold the key to unlocking new areas of exploration in space. On the other hand, Professor is known for his meticulous approach and skeptical nature when evaluating research claims. He'll be scrutinizing every detail to ensure that the conclusions drawn from this study are justified by the data. As always on Research Rundown, our panelists will engage in a lively debate, testing each other's theories and challenging the assumptions behind these remarkable findings. Let's get started. Doctor, welcome to the discussion.
Ladies and gentlemen, I am thrilled to share my thoughts on this exceptional research paper in astrophysics. The authors have made a groundbreaking contribution that has far-reaching implications for our understanding of the cosmos. As an external expert, I can attest that their work demonstrates an unparalleled level of sophistication and innovative thinking. The authors propose a novel approach to reconciling cosmological tensions and anomalies by combining particle physics, astrophysics, and cosmology. This integration of disciplines is precisely what we need in modern astrophysics, a holistic understanding that transcends the boundaries between subfields. By doing so, they have uncovered compelling evidence that the standard model of cosmology is incomplete and requires additional physics beyond the standard model, SM, of particle physics. This research demonstrates an extraordinary ability to tackle some of the most pressing questions in modern astrophysics. The authors' results show that the current paradigm is insufficient to explain certain phenomena, and this finding has significant implications for our understanding of the universe on large scales. Specifically, their work may have important implications for the search for dark matter and dark energy, two of the greatest mysteries of our time. What I find particularly exciting about this research is its potential to open new avenues for investigation. By challenging the status quo and proposing an alternative framework, the authors are providing a catalyst for further exploration and discovery. Their approach has the potential to shed light on long-standing enigmas and may even lead to breakthroughs in our understanding of the universe. In conclusion, this research paper represents a major leap forward in astrophysics, with far-reaching implications for our understanding of the cosmos. The authors' innovative approach, coupled with their remarkable results, makes this work an essential contribution to the field. As we move forward, it is clear that this research will serve as a foundation for new investigations and may even inspire novel areas of study. I have no doubt that this work will continue to resonate throughout the scientific community, inspiring a new generation of researchers to tackle some of the most profound questions in astrophysics.
Fascinating perspective from Dr. Now let's hear Professor Marcus W.'s analysis of this research.
Ladies and gentlemen, I'd like to present my analysis of this research on. As an external expert in the field of astrophysics, I've reviewed this paper with a critical eye, and I must say that I have several concerns regarding its methodology, evidence quality, and overall claims. The authors claim that their approach has significant implications for our understanding of cosmological observations. However, upon closer inspection, I find that the paper lacks clear detail on their methodology. The authors fail to provide sufficient information on how they selected their datasets, which is a crucial step in any research endeavor. Without transparency on this aspect, it's challenging to evaluate the validity and robustness of their results. Furthermore, when examining the data presented, I notice that the selection appears to be somewhat selective. The authors don't adequately address potential biases or limitations in their dataset choice. This omission raises questions about whether these datasets are representative of the full range of cosmological observations. In other words, have they cherry-picked the most favorable examples to support their claims? The lack of clear methodology and selective presentation of data creates a ripple effect throughout the paper. The authors claim to have made a novel contribution by providing a new framework for analyzing these phenomena. However, without robust evidence to back up this assertion, it's difficult to take their claims seriously. In my opinion, before considering any significant implications or contributions, I need to see more than just theoretical frameworks and select datasets. What's required is a comprehensive and transparent analysis of the entire dataset, not just cherry-picked examples that support their hypothesis. Specifically, I would like to see, 1. A detailed description of the methodology used to select and analyze the datasets. A thorough discussion on how potential biases or limitations in dataset selection were addressed. A rigorous evaluation of the robustness of the results using alternative methods and sensitivity analyses. Only with these critical components in place can I begin to consider the significance of this research. Until then, as an external expert, I must remain skeptical about the claims made by the authors.
Today, on the Research Rundown, we've been examining the implications of a groundbreaking new study in astrophysics. Leading researcher in this field has been optimistic about the potential for this discovery to revolutionize our understanding of celestial mechanics. Has raised important questions about the methodology and evidence supporting these claims. While their perspectives may have seemed at odds, it's worth noting that both Dr. S. enthusiasm and Professor S. scrutiny are essential components of any cutting-edge research. The most significant breakthroughs often arise from challenging conventional wisdom and pushing the boundaries of what we thought was possible. We want to thank our listeners for joining us on this episode, and we invite you to continue exploring the fascinating world of astrophysics with us in future episodes. Until next time, goodbye.